Hello class 10th. In this lecture, in the last lecture we have discussed about the refraction of light, the light when it was going from rarer to denser medium and denser to rare medium at different angles. Now again I am continuing the topic why the light is bending from its original path. I had given you explanation about this. When the light changes its medium, the velocity of the light changes and hence the path of the light changes, means it deviates from its path because of the change in velocity of the light when it enters the second medium. Now see again, in this diagram, this you are able to see this is glass. Suppose this is denser medium and above one is air, the rarer medium. Instead of naming that rarer denser air glass, I am naming A, medium A, and this one as medium B. The light is going from medium A to medium B. The angle of incidence in medium A is I and the angle of refraction in medium B is small r. At this time, the refractive index will be, you know that refractive index is what? The sine of angle of ratio of the sine of angle of incidence to the sine of angle of refraction. So refractive index mu is equal to sin I by sin r. At this time, you will not write only mu. You have to write A mu B. Why A mu B? A mu B means the light is coming from medium A and going to medium B. That is why you will write A mu B. But how you will pronunciate it? How you will speak about it? You will say refractive index of medium B with respect to medium A. A mu B is what? Refractive index of medium B with respect to medium A. Remember this point, at many places this will come. So when the light is going from medium A to medium B, you will write A mu B, but you will speak refractive index of medium B with respect to medium A. And one more thing, A mu B is equal to what? Sin I by sin r. The angle I must be in the medium A. You can see the angle I is forming in medium A, and in the denominator r. The r is forming in medium B. See here. So this also represents A mu B, means in the A the angle of incidence is I, in the medium B the angle of refraction is r. And one more thing, this refractive index is also described by the equation of the ratio of velocities in the mediums. Again, just remove this. A mu B is what? Sin I by sin r. This can be also written as the velocity of light in medium A to the velocity of light in medium B. What was the velocity of light in medium A? Let's see the detail of these in sheets. So the speed of light in a medium. So you have seen the refractive index is equal to sin I by sin r, but I said, so whatever is the medium where an angle I is formed will be written here, and whatever the medium where the angle r is forming will be written here. So as if you know that, suppose this is the normal, this is the light is turning in this way, this is the medium A, this is the medium B, this is angle I and this is angle r. So in which medium the I is forming? In medium A, and in medium B the angle r is forming. So what you will write? A mu B. And how you will speak? The refractive index of B with respect to A. And I said this will be also the ratio of what? Velocity of light. So what you have seen in the next line, the speed of light in medium A to the speed of light in medium B. This is another definition to describe what the refractive index. But remember, this A must be in above and B must be in the lower. If suppose it is B mu A, then you will write a speed of light in medium B with respect to a speed of light in medium A. So again, suppose this medium is air and this is any medium. This is any medium. So what will be here? We know that the speed of light in air, we know that the having symbol, speed of light has symbol small c, and speed in any medium, suppose small v. So the refractive index will have the another equation, this one. And one more thing, this is for you, this is very important examination. It is asked what? This is very important line, and don't forget, the frequency of light will never change while changing the medium, means while going from medium A to medium B, what by means going from any medium to any medium, frequency of light will never change, and velocity is equal to frequency into wavelength. So using this concept here, what you will see, the refractive index is equal to, C is what, f into lambda, this was in medium air, so I am writing here A, upon frequency into wavelength in medium B, so B, the frequency and cancelled because frequency is same. So another equation what you got for the refractive index is lambda A upon lambda B. Now I am writing in a common line. On writing the all complete in one line, A nu B sin I by sin R, velocity of light in medium A upon velocity of light in medium B. If the A is air, so this will be changed to small c, and this in medium B, any velocity is equal to lambda A, wavelength in lambda A, wavelength in medium A to the wavelength of medium B. So this is all in the single line. So now let's see the next topic. Our next topic is lateral displacement. What is lateral displacement? Let's see here. When the light was entering, you have seen only refraction on the first surface. See here, suppose this glass slab is here, the light is coming, this is the incident ray with the normal angle of incidence is I. The angle of refraction is R, the light is refracted. Suppose this medium was not here, so light will have this original path. But again, the light is going out right now. Means it is called emerging now. The light is emerging from this glass slab. What will happen? When it was entering in the denser medium, it was bent toward the normal. Now it is going out from the denser to rarer. So it will be bending away from the normal. See here, bends away from the normal. But what will be very special thing is, the special thing will be the original path of the incident ray and the emergent path will be parallel to each other. So what you have seen, the original path is shifted to here. This is shifted line. This is called perpendicular shift, and in general the lateral displacement. So this shift, the perpendicular shift from the original path and the emergent path, between the original path and the emergent path, is called lateral displacement. Let's see in the sheets. See here the lateral displacement. So I have taken one denser medium. Consider this is medium air, the above one medium A, and this one is medium B, the denser medium. The incident ray, the normal, the angle of incidence, the refracted ray. As the light is going from rarer medium to denser, it bends toward the normal. Now this light ray is going from denser to rarer back, so it will bend away from the normal. So let's draw the normal first. So see here the normal. At this time, what will be the angle of incidence? For that, see here the angle of refraction, this one. So now, what will be the angle of incidence here? So see, this one and this one both are normal, means parallel to each other. So this one will be equal to this one by the rule of alternate angle. So now what will happen? The light ray will bend away from the normal, but in which direction? Before that, I want to show you the original path of the incident ray. If there was no medium, so the light would have gone through this way. But now the light will emerge from here. Let's see in which direction. So see here, this ray is called emergent ray. As incident ray, refracted ray, this one is called emergent ray. So this angle is also known as with the angle E. But you can see here, this ray and this ray, means original path of the ray and the emergent ray, both are parallel to each other. So if this is angle I, so by the vertical opposite angle we can consider by shifting this ray here. So this angle I will be equal to this angle I also here. So what you have seen, there is a shift. This was the light ray, but is shifted to this way. The light was going in this direction, but by placing this denser medium, the light has shifted its path. Instead of going through this path, the light is going from now through this path. So this is what the shift. This is what the lateral displacement, called lateral shift. So the definition is the perpendicular shift or perpendicular displacement or perpendicular distance between the original path of the incident ray and the emergent ray is called the lateral displacement. See this is the perpendicular shift. Whatever be the value of this distance, this is lateral displacement. The perpendicular shift between the original path of the incident ray and the emergent ray is called lateral displacement. Now the next point is, on how many factors this shift depends. On how many factors this perpendicular shift depends. See here. So first one, lateral displacement is directly proportional to the angle of incidence. Means you can say directly proportional to angle I. Means if you will increase this value angle I, so this shift will also increase. If you will decrease the angle I, this will also decrease. See the next point, lateral displacement is directly proportional to the refractive index of the medium. Means whatever the refractive index of this value, this depends, this shift is depending on that. So if the refractive index value will be more, so shift will be more. See, the directly proportional. Next point is lateral displacement is directly proportional to the thickness of the medium. Means this thickness from here to here, suppose this is the thickness of this medium, so the shift is depending on this value. How? Directly proportional. Directly proportional to T. If thickness will increase, so this shift will also increase. Next point, lateral displacement is inversely proportional to the wavelength of light. Inversely proportional to the wavelength. Means if this light ray is red, so this will be less, and if this light ray will be in violet, so this shift will be more. So it is depending inversely proportional to the wavelength of light. If the wavelength will be high like red, so the shift will be less, and if the wavelength will be less like violet, so this shift will be more and more. Our next topic is principle of reversibility. See here, the light, the incident light, suppose AB, you can say the incident ray is coming toward the second medium. Suppose it is any medium. The above medium is A and the denser medium is B. The light is entering in the second medium and there is refraction phenomena is going on. So you can say here the sine of angle of I to the sine of angle of R is equal to A mu B. Equation 1. Now I am placing a mirror just perpendicular to the refracted ray. What will happen? The light will retrace its path. The light will go to the original path but in return. Now when it is returning back, what is the angle of incidence? What is the angle of incidence here when the ray is going out? The incidence angle becomes angle R. This is the angle of incidence now. The I and R only symbol. It doesn't mean R will be always for refracted angle. Here the angle of incidence becomes R, the angle, because the light is going out. So angle of incidence is R and angle of refraction is I. So what do you write? Sin R upon sin I is equal to B mu A, because I said whatever the angle in which medium. R is the angle in which medium? Medium B. So you will say the sin R by sin I is equal to B mu A. How it is going to prove the principle? Let's see the sheets. Now see the next point, principle of reversibility. For this you can take any medium. So here I have taken, suppose it is any medium of any refractive index. I am taking, suppose this medium is having medium B. This medium is B and the above one is medium A. Let's draw the incident ray. You can take any shape of medium, any shape of any material. I have taken in this shape. So the light ray is coming toward this way. So incident ray with the normal. So this is the angle of incidence. Now let's draw the refracted ray. Now you can see the refracted ray and say this is the angle of refraction. Now let's put the Snell's law for this interface. The light is going from the medium A to medium B. Let's write the Snell's law. That is sin I by sin R. Sin I in medium A and R in medium B. So what you can write? A mu B. Light is going from A to B. That is why this way, and I in A, R in B. This is here equation 1. And now place one mirror here. This mirror will be such that the incident ray will be perpendicular on this surface. When this ray will be perpendicular on this mirror, so the light will reflect and it will retrace its path. The light will go to the same path. So now what is the angle of incidence? Now the light is going from denser to rarer. What is the incident angle? Angle of incidence will be R and angle of refraction will be I. Let's try the Snell's law with the light going from this medium to other. light is going from medium B to medium A, sin R by sin I. So this will be refractive index, but R in medium B, I in medium A. So you will write B mu A as equation 2. Now multiply equation 1 and 2. Sin I by sin R into sin R by sin I is equal to A mu B into B mu A. Now you can see sin I is cancelled, sin R is also cancelled. So 1 is equal to A mu B into B mu A, or B mu A is equal to 1 upon A mu B. So this is the principle of reversibility. To clear this more, suppose A mu G, the refractive index of glass with respect to air, is equal to 3 by 2. So the question is, calculate the refractive index of air with respect to glass. So what will be that? This will be reciprocal of that, 1 upon 3 by 2. It becomes 2 by 3. So refractive index of glass with respect to air 3 by 2. Refractive index of air with respect to glass 2 by 3. Okay, this is all about principle of reversibility. Here you can also see the practice problem 1 says that the ratio of sine of angle of incidence in water to the sine of angle of incidence in air, this should be the refraction in air, is 0.75. Means sine I in water, see this, and sine R in air, same way it is. Sine R in water, this is angle of incidence when light goes from here to here. So sine I in water, according to question, this is the angle of incidence. So angle of incidence in water, so we can consider this. An angle of refraction in air, and this is what? 0.75. So when the light was going from B to A, so this equation was here. So what is the value of that? 0.75. Means you can say here B mu A is given 0.75 according to question, this one. And asking what? A mu W, because it is taking the second medium water. I am considering the second medium as B. So asking what? A mu B. This will be what? 1 upon 0.75. So this will be what? The 4 by 3 or 1.33. This will be value of A mu W or A mu B, whatever you can say. So this is the first question also. Here I am ending this session. In the next lecture we will discuss about the real depth and apparent depth and other topics. Till then, be safe, take care, and thank you.